Now in this period of algebra, from second chapter we are going to start next topic, root of positive rational number. Now here we know that Hex Sphere. Suppose X square is equal to 2. If you take square root of both sides, then we get, take the square root, we get x is equal to root 2 or x is equal to minus root. That means we have two square roots of 2 plus root 2 and minus root. That means root 2 and minus root 2 both are irrational numbers. Similarly, cube root of 7. This is also irrational number. Fourth root of 8. This is also irrational number. So suppose in this number n is positive integer. So n is positive. X raised to n is equal to 8. After taking square root we get x raised is equal to nth root of a. Nth that means x is equal to nth root of a. We can write in radical form. So here and suppose fifth root of 32 is equal to 2. And if x raised to 5 is equal to 2, then x is equal to fifth root of 2. Now here fifth root of 2 is irrational number. So using this concept we will study surds. Now we are studying surds. So what are surds? In short, surd is an irrational root. So here, if n is an integer greater than 1 and if a is positive real number and nth root of a is x, then it is written as x raised to m is equal to 8 or nth root of a is equal to x. And if this value x of x, that means this value is irrational number, then it is surd. If a is a positive rational number and nth root of a is x, and if x is irrational number, then x is called a surd. That means surd is an irrational root. For example, now In this surd, suppose this is a surd. Now in this symbol is called a radical symbol. This is radical symbol or radical sign. And here this n is called order of the surd. N is called the order of the surd, and A is called radicand. A is called radicand. See here. This is radical sign. This is the order of the surd, and this is called radicand. For example, see here, fifth root of 3. This is irrational root. Now in this, n is equal to 5. That means order of the surd is 5. And here radicand is 3. Now here in this example, here order is 2, but 2 is not written. If any number is not written here, then it is assumed that here order is 2. That means here order of the surd is 2. And radicand is 7, like that. Now see here some examples. We will have some examples of surds. Now see here example 1. Cube root of 7. Here cube root of 7 is, this is an irrational number. So therefore it is called surd. Now we see here another example. Now see here cube root of 27. We know that cube root of 27 is equal to 3. Here order is 3. And cube root of 27 and 3 is not irrational number, but it is rational number. And 3 is rational number. That means here cube root of 27 is rational number. So here this number, that means cube root of 27 is not surd. Therefore this is not surd, but this is surd, because this cube root of 7 is irrational number. Therefore it is surd. But cube root of 27 is 3 and 3 is rational number. Therefore it is not surd. Now see these surds. Root 3, root 7, root 42. So order of each surd is 2. Order is 2. And such surds are called quadratic surds. That means quadratic surd means if the order of surd is 2, then it is called quadratic surd. These are the examples of quadratic surds. But suppose cube root of 5. Here order of this surd is 2. Order is 3. That means this is not quadratic surd, because order is 3. If the order is 2, then it is called quadratic surd. Now we'll see the simplest form of the surd. For example, root 48. We'll convert this surd into its simplest form. For that, find the factors of 48 such that one factor is perfect sphere. That means 16 into 3. 16 3s are 48. These are the two factors. In this, 16 is perfect square. This is a perfect sphere. So one factor must be perfect sphere, so that we can simplify the surd. Now take the square root of 16. Square root of 16 is 4. And here remains in the root 3. So this is the simplest form of this. This value and this value is equal. This is called the simplest form of the surd. Second example, under root 98. Right, two factors, that means 49 multiply 2. One factor is perfect sphere, that means 49 is perfect sphere. So square root of 49 is equal to 7 under root 2. This is the simplest form of the surd. Now the like surds or similar surds. Like surds or similar surds means two surds are said to be like surds or similar surds if their order is equal and radicands are equal. That means order must be equal and radicands must be equal. For example, so in this surds, order of each surd is 2. That means orders are equal. And radicands are 5. Radicand means the number under this radical sign. 5, 5, 5. That means order and in each surd order is equal and radicands are also equal. So such surds are called similar surds or like surds. For example, here cube root 13, 2 cube root 13. Now here also order of each surd is 3 and radicands also equal 13, 13. So these are also like surds or similar surds. Now we will see now here these two surds are here. In these two surds orders are equal. But what about radicands? Here radicand is 45 and here is 80 are not equal. But we cannot say that these are like or not similar or similar. First we have to simplify and then we can say that these surds are similar or not. First we will simplify this. We will write these two surds in their simplest form. Then we will determine whether these two surds are like or not. So 45, root 45 can be written as root 9 into 5. That means 9 5s are 45. Here 9 is perfect sphere. And square root of 9 is 3. Root 5. Factors of 18 are 16 into 5. 16 is perfect sphere and square root of 16 is 4. Now here in both the surds, here order is 2, order is 2. This is not order. 3. These are coefficient. Order is written here. Here order is 2. If there is no number, it is 2. And radicands are equal now. Therefore, these two surds are similar surds. That means here similar or like surds. Comparison of surds. Comparison of surds. Now if A and B are two positive real numbers, then if A is less than B, then if you sphere both the terms, squaring both the terms, we will get A square is also less than B square. That means if A is less than B, then A square is less than B square. If A is greater than B, then A square is greater than B square. And if A is equal to B, then A square is equal to B square. Now we will use this concept for comparison of surds. Now we will have some examples. For example, compare the surds. These are the two surds, 6 root 2 and 5 root 5. Now we have to compare which surd is less and which surd is greater, or both are equal. So here we know that here so which symbol will be here? We have to compare here. So if we take square of both the sides using this, so here we get 6 root 2 square and 5 root 5 square. Okay. Now square of 6 is 36 and square root 2 is 2. Now square of 5 is 25 multiplied by square of root 5 is 5. Now 32 multiplied by 2 we get 72. And 25 multiplied by 5 we get. Now see in these two numbers 72 is less, 125 is greater. That means 72 is the value of square of this surd and 125 is the value of square of second surd. That means here second number is greater, first number is less, and therefore here 6 root 2 is less than 5 root 5. In this way, you can compare the surds. Now in next period, we will study the operations on like surds.